today in this video we'll be solving some numericals based on errors, which the theory for which we have already studied in the class. For that, the first numerical is the percentage errors in the measurement of mass and speed are 2% and 3% respectively. How much will be the maximum error in the estimate of kinetic energy obtained by measuring mass and speed? For that, first we'll write down the given terms. Here, the percentage error in the measurement of mass and speed. To write the percentage error in the measurement of mass, I can write del n by m into 100 is equals to 2%. Similarly, the percentage error in the measurement of speed, as speed is denoted by v, therefore delta v by v into 100 is equals to 3%. How much will be the maximum error in the estimate of kinetic energy? As you all know, children, the formula for kinetic energy is kinetic energy is equals to half mv square. I'll write instead of k, I'll write it as E because I need to find out the percentage error in kinetic energy so that it would be easy for me to denote. That's the reason that I have taken only E. Now, to express this in the form of percentage error, 1 upon 2 is a constant for which error cannot be expressed because it's a fixed value. So, we'll find out the percentage error for the variables. Now, for that, I'll write del E by E into 100, that is the percentage error in kinetic energy, will be equal to, since it involves the product of two terms, I can write it as del m by m into 100 plus, now it's the error involving powers, so I'll write 2 times del v by v into 100. Now we can substitute the values. By substituting the values, we get del m by m into 100 is directly known to you as 2%. So it will be 2% plus, it would be 2 times, you know, del v by v into 100. So it will be 2 into 3%, which would be equals to 2% plus 6%, which comes out to be equals to 8%. So this is the result. The second question is, a physical quantity Q is given by Q is equals to a square b to the power of 3 by 2, c to the power of 4 and d to the power of 1 by 2. The percentage errors in A, B, C and D are 1%, 2%, 4% and 2% respectively. What is the percentage error in the quantity Q? Now, dear children, in this question, Q is a physical quantity which involves the product of two quantities as well as the quotient of two quantities, right? So, we need to apply, and also they involve powers. So, we need to apply the result of the product, the powers and the quotient ones. So, here 3 rules would be applied. So, in order to find out the percentage error in Q, we could write del Q by Q into 100 is equals to, now first I'll apply the product rule for power rule for A square, that is 2 times del A by A into 100 plus the product rule, again the power 3 by 2 del B by B into 100. Now again and apply for the quotient. For quotient again the errors are added up, that is 4 times del C by C into 100 plus 1 by 2 del D by D into 100. Children, you should be very careful in solving such type of numericals because many children make mistakes by taking this as minus 1 by 2. The power. You don't need to take the power to the numerator. We directly applying the rule here. That is the product rule as well as the quotient rule involving the powers. Then we need to directly apply the given values, that is 2 times, what is the percentage error in A given as? It's given as 1%. So we'll write it as 2 into 1% plus 3 by 2 into, what's the percentage error in B given as? It's 2%. So it would be 2% plus 4 times del C by C. What's the percentage error in C? It's 4%. So into 4% plus 1 by 2 times del D by D is again 2%. So multiply by 2%. Right? So what's the result that we are going to get? It is 2 into 1% is 2% plus 2 gets cancelled. So you'll be left with 3% plus 4 into 4 is 16% plus 2 and 2 get cancelled. So you are left with 1%. So the result would be 3 plus 2 5, 5 plus 16 21, it would be 22%. So that's the result. Now let's solve the third numerical. The period of oscillation of a simple pendulum is t is equals to 2 pi under root of L by G. Measured value of L is 20 centimeter, known to 1 millimeter accuracy. Children, what do we mean by this 1 millimeter accuracy? It means that it's an error in L. And the time for 100 oscillations of the pendulum is found to be 90 seconds. What is it? It's the time period. Using a wristwatch of 1 second resolution. If the wristwatch is having 1 second resolution, that means an error in the time period is 1 second. What is the accuracy in the determination of G? That means we need to find out the percentage error in G. For that, we'll start with the known formula. We know that T is equals to 2 pi under root of L by G. Now, in order to remove the root sign, what we would do? We would square both the sides. That is, T square is equals to 4 pi square L by G. Now, as we need to find out the percentage error in G, I'll transpose G to one side. So, G would be equals to 4 pi square L by T square. Now, I would apply the rule for errors. Applying the rule for errors, del G by G into 100 will be equals to 4 pi square. These are constants. So, del L by L into 100 plus T square it is. So, 2 times del T by T into 100. Now, we will substitute the values. That is, del G by G into 100 will be equal. So, what is the error in L? The error in L was accuracy, 1 millimeter of accuracy. 1 millimeter means how much centimeter? It is 0.1 centimeter. So, I'll write it as 0.1 upon how much is L? L, del L is 0.1 centimeter and the value of L is 20 centimeter. So, into 20 upon 20 into 100 plus 2 times, what is delta T? Delta T is 1 second of resolution. So, it is 1 upon, what is the time period? Time period is 90 seconds. The time period is 90 seconds. So, I will write it as 90 into 100. Now, we will solve those values. It would be 1 by 20 into 10 plus 20 by 0, 0 gets cancelled. It would be 20 by 9. So what do we get? 1 by 2 is 0.5 plus 0.5, I can write it as percent, plus 20 by 9 would be 2.22%, right? So what would be the final result? It would be 2.72%. The fourth question that we are going to solve is not related to errors, but it's related to the topic that we have already studied in the beginning of the chapter. Here comes the question. The velocity of a particle depends on time t as v is equals to at square plus bt plus c, where v is in meter per second and t in second. What are the units of a, b and c? So children, you are supposed to find the unit of a, b and c. A, b and c may be a variable, it may be a constant, as there are certain constants which has got units. So in order to find out that, the left hand side of the equation has got only one term, whereas the right hand side consists of 3 terms. So each term on the right hand side should be the same, should be equated to the term on the left hand side, as only same terms can be equated or added or subtracted, right? So if v is a velocity, that means v should be equals to at square, right? So I'll take up the term individually. So the first part, so in order to find out a would be equals to v by t square. Now you know that v is having the unit as meter per second, so it would be meter per second upon, and t is in second, so it would be second square. As you solve, it would be meter per second cube. So what is the unit of a? So a has got a unit of m. It would be m s to the power of minus 3. That would be the unit of a. Similarly, in order to find the unit of b, v should be equals to bt. So b would be equals to v by t. You know that it is meter per second upon second, so it would be meter per second square. And children, you already know which is a physical quantity which is having the unit as meter per second square. Now it is acceleration. So the unit of b would be meter per second square. That means b would be acceleration. Now the last term is c. For c, you can have b is equals to c. B should be equals to c. So what is the unit of v? V is equals to meter per second. That means it should be m s to the power of minus 1. So what are the answers? Answers are meter s to the power of minus 3, meter per second square, and meter to ms to the power of minus 1. So these are the answers. Hope children you have understood the numericals. Thank you.